Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all my beloved students. This time we will learn how to solve the problem related to the pure substance, specifically to fill up the property tables. This is the question related to the property table. We need to determine the missing property and phase description. We are given temperature, pressure, enthalpy, quality, and phase description. So let's say in the question give us another type of property such as internal energy denoted by U or specific volume denoted by V. So we can also determine or solve the problem accordingly based on the same approach. This is the step of solution to assist you to solve the problem related to the properties table. First, referring correct property table, of course, we need to refer the correct property table. Let's say for the case of question related to the water, you may refer to the property table for water. In the case of the question related to the refrigerant, so you need to refer the property table of the refrigerant. So you need to be careful on that. Otherwise, you may have a wrong for the entire solution. Step 2, ensure at least two information provided. One of it must be either temperature or pressure. So you just need to concern on this because to solve the property tables problem, you need minimum two information. It can be either temperature or pressure with the other's property. Thirdly, remember the characterization of compressed liquid, saturated liquid vapor mixture, and superheated vapor. This is the crucial part. You must remember because when you have the difficulty to determine the characterization, so it may lead to the wrong justification to solve the problem. And finally, step 4, if saturated liquid vapor or mixture, always deal with the quality or X. So knowing that the saturated liquid vapor or mixture in the range of the 0 until 1, which is you need to determine the X by using the formula and or manipulate the formula to obtain the desired value of any specific properties. Step 1, referring correct property table. Knowing that we only have two types of saturated water table, either pressure or temperature. So we need to use this table based on the information given from the question. For example, let's say the question gives us information related to the pressure. So we need to refer the pressure table to solve the problem. Step 2, ensure at least two information provided. One of it must be either temperature or pressure. If you notice from this table or question, you will give minimum two information, okay, and one of the information from either temperature or pressure. Number 3, remember the characterization of compressed liquid, saturated liquid vapor mixture, and superheated vapor. So we need to remember the characterization for compressed liquid, superheated vapor, because it will lead us to determine the region of the water. And also, so urge you guys to remember this 5 dotted, first dotted, compressed liquid, second dotted, saturated liquid, third dotted, mixture, fourth dotted, refer to the saturated vapor, and lastly, dotted number 5, superheated vapor. Let's try to solve this question. We are given P 500 kilopascal and X equal to the quality 0.6. Firstly, refer to the quality information, which is you are given 0.6, knowing that the mixture region or saturated liquid vapor in the range of 0 until 1. So automatically we know the answer for the first description is saturated liquid vapor or mixture. Okay. And then we need to solve the temperature and the enthalpy. To solve this one, we need to refer the property table. If you remember how to determine the correct property table, it's quite straightforward. Since the information gives us related to the pressure, so we refer to the saturated water for the pressure table. And then we try to look at the value of the pressure, which is 500. So we refer to 500, and then we get the answer 151.83 degrees C. It's quite straightforward, right? And then after that, how to determine the enthalpy? Same also, but you need to careful to refer the which column of it, because enthalpy denoted as H, internal energy denoted by U, and specific volume denoted by V. So of course, for this question, we refer to the H column or enthalpy. Okay, so I will try to segregate this thing, and then try to do this one. Okay, meaning that why I'm highlighting that information, because to determine the H, we need to use the equation related to the quality. Since HF is available from the table, X from the question, and FG we pick from the table. So finally, we can get this final answer, 1904.9. Let's say the question asks for internal energy or specific volume. We just change the symbol from H become U, okay, become U, or from H become V. So it based on the question. Let's say you are not given the information related to the HFG. For example, in the case of V or specific volume, they are not give us the information related to the VFG. So how to determine the HFG? If the HFG in the table is not available, okay, let's say it's not available, so HFG actually equal to the HG minus HF. So let's say the table not give you the information related to the HFG directly, so you can still obtain the information by subtracting the HG with HF to determine the HFG. Let's do the question number 2. We are given temperature 160 degrees C, enthalpy for H are 2000 kJ per kilogram, and we need to determine the P, quality, and phase description. Firstly, we need to refer the property table. So since the information gives us related to the temperature, so we need to refer the property table based on the temperature. And then straight away we go for the temperature of 160 degrees C, and we can get straight away the pressure is the 618.23 based on the information. Next, we need to determine the quality and the phase description. So of course, since the question gives us the information related to the enthalpy, so we refer to this section, enthalpy. And then, based on the 160 degrees Celsius, we refer the information of the H and Hg. And then we find out from the enthalpy column, for HF is 675 and for Hg is the 2757. So noting that the 2000 is in the range of the HF and Hg. So we can conclude that the region or the phase description of this property is the saturated liquid vapor mixture, because H in between the HF and the Hg. And knowing that the phase description is the saturated liquid vapor mixture, so we need to determine the quality or X by using the equation of the quality, which is H equal to the HF plus X HFG, and insert the information of the 2000 here. HF is 1, Hg is 1. So finally, we can obtain the X value. So the final value for the quality is 0.48. Next, let's do question number 3. We are given P 800 kilopascal and quality equal to 0. And then we need to find temperature, enthalpy, and phase description. Okay. So from this question, automatically we can know actually what is the phase description based on the value of the quality. If you still remember this graph, we deduct that X equal to 0 equivalent to the condition or region of the saturated liquid. So straight away, regardless or referring the others information, we know the answer is the saturated liquid. And then next, we need to determine the temperature and enthalpy. So of course, this one we need to refer to the table. Since the information gives us the information of pressure 800 kilopascal, so we refer to the table, property table, based on the pressure information. So refer to the 800 kilopascal, and then we can get the temperature straight away, 100.41. Okay, so we solve the information for temperature. And then next, we need to determine the H or enthalpy. So still referring to the table, we know that the H equal to the HF due to the X equal to the 0. And then just refer to the table of the property, we can get the HF equivalent to the 720.87, and then we can get the answer is like that. So it's very simple. Next, this question gives us information on temperature and pressure, which we need to determine the enthalpy, quality, and phase description. To solve this problem, firstly, we need to refer the pressure table to determine the T set, and then compare the T set with the T equation. After that, we determine the H by referring the temperature table. Let's have a look. As mentioned just now, so we need to refer the pressure table, and based on the 500 kilopascal, according to the question, we determine the T set equal to the 151.83, and then we compare the T equation, which is 80, with the T set, and we found that the T equation is lesser than the T set, which refer to the answer of the first description is compressed liquid. Then, after we get the first description as a compressed liquid, so automatically we can answer the quality, which is dash or nil or not available. Because what? For the compressed liquid region, there is no such thing, the value of the quality. But normally, a student may put the quality equal to the 0, which is wrong, because 0 represent the condition region for the saturated liquid. So you guys need to be careful on that. After that, to determine the enthalpy, as mentioned just now, referring to the temperature table. Okay, temperature table with the question 80 degrees C. And then since the question asks about the enthalpy, so we refer to the enthalpy, which is HF. Knowing that the HF more or less with the H value due to the compressed liquid region. Okay, so H at HF at 80 degrees C equivalent to the 33502. So that's the final answer and step of solution when we are facing the problem with the given temperature and pressure. This question gives us information related to the pressure and the quality. So by looking from this question, we can straight away answer the first description because the quality equal to 1. If you still remember the graph of the PV diagram related to the 5 dotted, x is equal to 1, quality equal to 1, equivalent to the condition or the phase for saturated vapor. So straight away we can answer the first description question. Next, we need to determine temperature and enthalpy. So we will start with the temperature, and then afterward we will solve the enthalpy. So of course, since the question gives us the information related to the pressure, so we refer the saturated water pressure table. But this kind of condition, we are not given exactly the value of P equivalent to the 8 to 6 kilopascal, because in the table only give us the range of 800 kilopascal and the 850 kilopascal. To solve this problem, we need to do the interpolation. Let's say we want to solve the temperature, so we relate the information with the pressure and the temperature, and try to make this kind of table to assist you and to make it very clear. So P 800 refer to the upward, 850 is the downward, and 8 to 6 is the from question which we intend to solve. And then of course the available temperature on 800 is 170, 850, 172, and then T is the value we want to determine. And then by using the interpolation method, we can get the final answer of T equal to the 171.72 degrees C. It same goes to the enthalpy, because we also do not have any information for the H with 8 to 6 kilopascal. So with the same approach, to get the answer of the T, we apply with the enthalpy. But bear in your mind, you need to refer with the condition of the Hg, because what? X equal to 1 refer to the value of the Hg. And then after that, fill up in the table for the interpolation and specify the pressure to determine the enthalpy. And finally, based on the calculation, you may obtain H approximately 2769.6. So that is the final answer for the question number 5. This time, the question gives us information related to the pressure and enthalpy. And we need to find the temperature, quality, and phase description. Since the question gives us the pressure information, so we need to refer the pressure table as a part of our solution. Yet, go to the pressure 800 kilopascal, and then we check the H for 800 kilopascal to 47.5 to 768.3, and then we compare with the H from the question, and we found that H from the question is greater from the H value from the 800 kilopascal. So we can conclude that the phase or region for this condition is superheated vapor. And of course, once we know the phase description is superheated vapor, so the quality automatically become dash or not available or nil, because at the superheated vapor condition, there's no value of quality. But normally, people or students will wrongly put x equal to 1, which is wrong. X equal to 1 refer to the saturated vapor. It's not refer to the superheated vapor. So, guys, you need to be careful on this. And then after that, we need to determine the temperature. Of course, knowing the condition of the question is the superheated vapor, so we need to refer to the superheated water table to determine the value of the T. Then just refer to the P equal to the 0.8 megapascal or equivalent to the 800 kilopascal, and then search at the enthalpy column with the 3481.3, and then you can get your temperature is 500. As simple as that. This is the question, more or less the same with the previous exercises. So you guys can try to do this accordingly. If you have the difficulty to solve, you can refer to the previous slide or the video. So also provide the final answer for each question so that you can cross-check your answer. And kindly please notify sir if any incorrect answer, especially related to the reference table as well as the calculation. With that, all the best. Assalamualaikum warahmatullahi taala wabarakatuh.